So, even if I'm Lithuanian, I'll do it in English simply because the topic and the terms are mostly in English, so it will be much more easier. So, as the guy said, my name is Justinas. I'm a very happy team member of Blue Ocean Robotics. We're a relatively new company. We focus on bringing new robotic products to the market, from early stage to working products, and getting all the way through, even through the Valley of Death that the head of university just mentioned. I have been building products the way I see myself for the last 10 years or even more. So, and computer vision, as I say, is something that got me into robotics. Very, very fascinating field. Today I have 3 stories for you. The first one is, how did we get here? And I will quickly explain what I mean by that. The second one is the range of applicability and adaptation, is meaning how far can we actually apply the technologies today, and what's the horizon to come. And the last one, the third one, is I think the most popular story of nowadays. I call it the short fair story of how actually the future of jobs look like when the robots take everything over. So to start from the beginning, the first story is how did we get here? And this is not a story on Big Bang or theory of everything or humans from Mars or anything like that. This one is about why we do what we do, and that is create machines, improve them, and thrive for more automation, either for fun or very serious practical reasons. And to start the story correctly, we have to look at one very fascinating recovery that we made in the beginning of 20th century. And it stayed uncertain for a long time. But after a long analysis and scanning and thinking it through, we actually figured out, and they got the name of Antikythera device, and that was the first clock mechanism, or as I would call a first mechanical computation machine that was so precise and so small that it would fit in your coat pocket. And it was actually designed very accurately to calculate the movement of moon phases, and to calculate the movement of sun, and probably even some other terrestrial bodies. And to understand the effect and the moment that it had in the old Greece, which dates back more than 2,000 years, you have to think that the device this small is actually a piece of mechanical art. It's made out of bronze. It's able to calculate very precisely. You have the full social effect with it. Like you're able to suddenly track depth, because in ancient Greece, people used to track depth based on the moon phases. So it suddenly becomes your external clock that you use for your everyday life, which starts to dictate your pace. And also it made this conceptual leap that I just explained. This is my favorite slide. I don't know if you see it, but I always have to say that, and then we lost Europe for another 1,000 years, because we had to wage wars, destroy everything we created in ancient Greece and everything else, just to start over. And we have to look once again at one more clock, or one more mechanical calculation device, which is at the 11th century. And just look at the size of it. Compared to the box that we had 2,000 years ago and this one, it seems that we still have not even a bit caught up to the previous technology. It's made out of wood and iron, it's huge, but it was doing exactly the same thing as the Antikythera device. It helped you keep the pace and helped you get your life around it. And as actually one French clockmaker very correctly pointed out, that the first clocks with gear wheels controlled by a balance actually were the main drivers or the main pacemakers for a passerby that would take a look at it, or the one who is not taking a look at it would actually hear it on the other side of the town. Here we have the concept where a small clock that you previously had is transferred into a tower, and it suddenly the clock starts controlling the city. So you suddenly have what Greeks called rhythmos. To jump from this to a bit further step is a very interesting story that happened in the medieval Silicon Valley or Nuremberg in Germany, where we had the first robotic arm that appeared as a very practical piece for one of the German knights who lost his arm, the right arm, and then he managed to get a fully mechanical, fledged robotic arm who was capable of delivering many sophisticated operations, like capable of holding objects. It had controlled finger movement, and it even had something that you would call today a position locking. So he could actually write, he could actually fight, and he could actually do a lot of things with this arm. So quite a spectacular piece for the time. To jump a bit further, or a bit back and then further, you have to connect the clocks, first of all in the Greece, and then in towns, and then you have to connect it to this strange mechanic robotic arm. And then you will start seeing what Leonardo was experimenting in the Renaissance with his first robot that was actually able to move arms completely automatically. That was a fascinating piece. And that was the birth of the automatons, or so-called the early term for robot. The next step was taken even further. The digesting duck that was presented by one Jacques in French, of course they're all Jacques. It was a fascinating piece of technology just because it so much affected people. They couldn't believe that this piece of mechanics could actually do exactly what a real duck was able to do. He was able to impersonate a living being by eating grain, pretending digesting it, and then actually pretending that it's defecating it. And it was completely mechanical. We're still talking only mechanics. The Swiss took it even further with an automatic scriber. A fully autonomous machine was able to write, looked very human-like, and this is 18th century, and this is also unbelievable. This craze of automating could be very quickly illustrated by a very short video. I will just show it for a minute. It's from a fantastic BBC movie on how far and how crazy actually the mechanical utopia was taken.
The form of an entire working city. The automaton was commissioned in the 1740s by this man, Archbishop Jakob von Dietrichstein. For him, the machine was the vision of a perfect society. A city populated by well-behaved, obedient, automaton subjects.
So here we can see, I will just pause the video at this time, simply because of the time. Here you can see the total craze of mechanical applicability and the ideal utopia of making everybody work in the clockwork town or clockwork universe. To stop here for the moment, before we jump into the 20th century, almost 2,000 years we have been building mechanical machines, trying to impersonate human beings. By this we started turning human beings, or trying to make them into more mechanical, more precise, or sort of so-called human automatons. And just to make them do things more precisely and exactly what we wanted. This all gave the rise to the first factories. This is, by the way, an image of an early Ford factory at the beginning of 20th century, and you can see a few concepts you are already familiar with. Both a human automaton and a clock, which is overwatching people and making sure that they keep up with a mechanical pace. And we have been really good at making them more precise, because it's an automaton. And we were trying to make less action and more accuracy. Less action and more accuracy, which led to a lot of ergonomic rules that came in later on, what was called as a predefined workspace, just because that you would limit the number of movements that you could make just to save time. And this all led to a very understandable and visual conclusion. To start my second story on the range of applicability, or as I'm very fond of calling, how far the robots will go. And I can tell you that they will go really far. And adaptation on how will the setup change so that the robots will keep going and keep expanding. We have to start from the infrastructure. And the infrastructure is something that is always forgotten or is always unseen for us because we take the world for granted. And infrastructure is the base on what we build everything. You see electricity today, you have communication, and you have forgotten already about it. But for us to apply and to automate things further on, infrastructure is the base that we build on top of it. And as my father actually has a very, very interesting joke. He says, if you would sum up the IQ of the machines that are around you typically in the room, it will be much higher than the person who is actually looking at these machines, because he has already forgotten that we have put all this knowledge in the machines already. And we are taking this infrastructure for granted. So the infrastructure opens up the range of applicability, which is to imagine how many different sectors or activities could be out there, that the key innovations could be productively applied. Manufactured once and applied many. Manufactured once and applied many. Which brings a really fast return of investment. A really fast one. And most importantly, it takes the existing base, the infrastructure, because it requires almost no changes. That means no extra investment, and that's why it's moving so fast. And we will very quickly jump into a lot of examples how this applicability is happening right now and today. We have developed something, or we have inherited something from our colleagues previously that we call the Genevke scale, which actually helps us determine in what stage the technology, or the robot technology in our case, is. And we use it to determine the complexity, to determine the investment needed, and to determine whether we're going for this product or not in development sense. So the scale starts at 1, which we call the simple standard solutions. It means you don't have to do a thing. It's already done. The process is clear. It's an off-the-shelf piece. You just take it and you use it. So it means that it's completely relying on the existing infrastructure. The second category is what we call the adapted standard solution. So there is a small variation in the previous version. So it means that it needs a bit of extension. The third one, the middle one, is the specialized solution. It means that you are doing a number of changes to the standard solution. You have to experiment a bit so that you are sure that this could be applied. But it's still working on the existing infrastructure. The fourth one we call the innovation. And in some senses it means that you will also have to invest a bit or change a bit in the infrastructure. You will have to do other changes, but it will require a much steeper and a much longer process. And the fifth one, which we call is the complete research, is that what mostly scientists and universities are placing and spending their time. That's something that is completely new and requires a lot of time just to begin investigating. So as I said, I want to very much repeat that and emphasize applicability starts on infrastructure. The range of applicability refers to the number of different sectors. Hence, the robot arm that we have just produced, try to think of how many industries could actually make use of it with no changes in the infrastructure, making it a very standard product. One more sample from the early 4 days, that they actually were optimizing the movements in the kitchen that could later on be automated. And you can see on the upper picture, which is the natural human movement, which is a complete waste of energy and time. And the second one, which has all the optimized movements, which actually lead you to these fantastic two guys. Please just think about these two flexible and robust robot arms moving in your kitchen. It requires almost zero changes in your existing infrastructure. The kitchen is there, the electricity is there, the robot is there. You just place it and it works. I would like to jump in a few more examples, and the first area that I would like to touch is the industrial assisting applicability area. I'm touching the assisting because the future of manufacturing and industry is actually moving very much towards assistive robotics. We're not talking about factories which are completely automated and are working on their own. We're talking about factories where humans are collaborating with robots for better efficiency. And I would like to show a quick video on one very fantastic product that I'm very much fond of.
Meet Baxter. Baxter is Rethink Robotics' flagship product in a revolutionary new category of robots with common sense. Baxter is a low-cost and highly adaptive robot for manufacturing applications and is so easy to use that non-technical workers can train it. Baxter increases workforce productivity so factories in the US can compete with low-cost offshore labor. And Rethink Robotics practices what it preaches. Our robots are made in America. Baxter can do manufacturing tasks like material handling, line loading and unloading, test and sort, machine tending, packing and unpacking, light assembling, and finishing operations. Baxter is a complete system requiring no integration. It can be uncrated and doing useful work in under an hour. While traditional manufacturing robots need to be programmed by expensive technical professionals, Baxter can be trained by non-technical personnel. Train Baxter to do a new task by just showing it what to do. No application software or teach pendant is required. So the people working with Baxter get a promotion from working on repetitive, mundane tasks to supervising robots that do them. Baxter has a suite of integrated sensors and the common sense to work intelligently. It adapts to the speed of the conveyor and variation in part placement and does human-scale tasks at human cadence. So unlike traditional automation, there is no need to redesign your workflow to accommodate Baxter. Baxter safely operates elbow to elbow with people. Its unique, compliant mechanical architecture lets Baxter give on contact. And Baxter automatically detects when a person enters its workspace, displays clear visual feedback, and slows down to increase safety. Baxter is an extensible platform like a PC or smartphone. You get regular software updates with new capabilities. Baxter is showing up everywhere, at small manufacturing firms that couldn't previously afford robots, and at large firms rethinking processes that weren't previously economical to automate. Rethink manufacturing, rethink offshoring, rethink robotics.
The next example I would like to touch is one of the products we're building, which is also an assisted robot, which is designed to assist a worker who is working in the field mounting glass pieces. It's optimizing the process where previously two people had to do the work. It's heavyweight, a lot of bad backs happen, and it's actually an assisted robot to assist person in doing a very hard physical job, a typical robotic application. Another one, which is also very well known, I think, for all of you, is a very big success story of Kiva Systems, or now called Amazon Robotics. A company which was, from the establishment to the selling in 2012, was only 9 years old, and Amazon bought the company for $750 million. On these robots, actually, Amazon is running all of their logistics now. If you would find a video on YouTube of how Amazon logistics looks like, you will see that it's completely, absolutely robotized and automated. That's how they got their traffic or the production optimization up 40%, just because of these robots. I would also very much like to touch on healthcare applicability. This is a very big sector that is booming right now and is seeing a lot of robots. I would like to start from the first and the second category, the products off the shelf, that are really the semi-automatic and low added value products, like cleaning, disinfecting, which actually are replacing the boring and ineffective work for humans. And the products are off the shelf. And a quick video of a product that we are actually making. A very low category, but a very, very understandable and a very needed solution. So now if we would move a bit further in medicine, telepresence robots can actually be applied in much more areas, but in medicine that is very much moving because of the elderly care, of the communication with the patients, the faraway doctors, and many other things. And telepresence solution is something that I would call category 2 and 3, which are used for constant monitoring, communication, which is an assistive system to the human being. It's not replacing it, but it's assisting. And it's also an off-the-shelf solution. The hardest category, or the toughest one, as I would call 3 to 5, is the so-called human repair robots. It's robots which are actually doing the repair work on us. And this is the most sophisticated work, and a number of machines are actually being produced in this area. It's also an assistive, or sometimes even replacement robot, because of the precision it can achieve, which humans could never achieve. It never gets tired, and it can do it much more precisely. And it's also an off-the-shelf solution, so it means that the infrastructure is already there. The third section I would like to touch is a very personal one, which is the home applicability area. What is happening in our homes right now that is already happening? Once again, the maintenance robots, the category 1 and 2, the boring work that nobody wants to do. Clean the floor, clean the floor, clean your, cut the grass. And it's also a semi-automatic and low added value work which humans don't want to do. And it's a fantastic human replacement because we get the processes done. Communicational robots for household is the category 2 and 3. You can resemble a bit to the telepresence robot, but these ones are much more personal. These ones are about assisting on a different level. I would like to show the last video, which is
This is your house.
on a very
This is your
interesting
car.
product from America.
This is your toothbrush. These are your things. But these are the things that matter. And somewhere in between is this guy. Introducing Jibo, the world's first family robot. Say hi, Jibo.
Hi, Jibo.
Jibo helps everyone out throughout their day. He's the world's best cameraman. By intelligently tracking the action around him, he can independently take video and photos, so that you can put down your camera and be a part of the scene.
Jibo, take the picture.
He's a hands-free helper. You can talk to him, and he'll talk to you back, so you don't have to skip a beat.
Excuse me, Anne?
Yes, Jibo.
Melissa just sent a reminder that she's picking you up in half an hour to go grocery shopping.
Thanks, Jibo.
He's an entertainer and educator. Through interactive applications, Jibo can teach.
Let me in, or else I'll blow your house in.
Hey, where'd you go? There you are.
He's the closest thing to a real-life teleportation device. He can turn and look at whoever you want with a simple tap of your finger.
Check out my ticket in, Mom.
I wish you would eat that.
Hey, maybe turkey pizza? I want turkey pizza.
And he's a platform, so his skills keep expanding. He'll be able to connect to your home.
Welcome home, Eric.
Hey, buddy. Can you order some takeout for me?
Sure thing. Chinese, as usual?
You know me so well.
And even be a great wingman.
You have a voice message from Ashley. Want to hear it?
Absolutely.
Hey, call me when you're home.
Better make that takeout for two, Jibo.
We've dreamt of it for years, and now he's finally here. And he's not just an aluminum shell, nor is he just a 3-axis motor system. He's not even just a connected device. He's one of the family.
Good night, Jibo.
Jibo, this little bot of mine.
What if technology actually treated you?
So that is category 3. Now the last and the most important one, which you have already seen, will be the household replacement ones, which will be cooking for you. We have touched on that already. To finalize on the applicability and adaptability, we have just touched the infrastructure and how it's easy to see a lot of solutions which are happening because the infrastructure is already there. Now, but what about the adaptability? Adaptability means that you have to expand the application horizon and that you have to organize the infrastructure. So we have to lay new base so that new solutions could be built on top of that. But it takes much more investments and it takes much more time because the old configuration will have to be changed and not necessarily it will all be there when you will reorder it. And the most recent example I think you can put is what Tesla is going through because they have only part of the infrastructure there. They have the roads, they have the communication, but they're struggling with batteries, struggling with charging stations, and that is something that will take them a long time because the infrastructure is still not completely there. And the last very quick story is the short story and fear of what will happen with our jobs in the future. Remember these guys, right? And how fun they were and how inspiring they were. The next thing that happened was that these machines which were initially created to be fun part of our lives actually became machines of labor. And we can look back at the Ludic findings in the 19th century or the first industrial revolution when humans really felt the first competition from the machines. Technological unemployment is a term that is also defined thanks to the machines through our discovery of economizing the use of labor. and the ways we want it to increase productivity. And to solve engineering problems in the factory, the other job-related challenge is to make things more productive. Once again, it's a loop. Productivity rises, but employment wilts. It means that it actually stagnates and starts falling little by little. So meaning that we actually create much more workplaces for robots in industry than we create for humans. And just to give you a brief, short few numbers, that in the 19th century, 41% of America worked in agriculture. In 2000, it was only 2%. In proportion to this, 30% of Americans in post-world wars, was working in manufacturing. Now, it's only around 10%. But the robots will not take over everything. Humans are moving to more servicing, to more personal areas, like health sector, janitors, restaurant workers, and many other service work that is actually really hard to automate. And there could be a separate talk about how much each industry could actually be automated. And there is a certain limit in every industry and in every application that you will have. So robots will never reach a level of 100%. More importantly, robots, as we have just seen, actually co-create new positions for human workers, improving and getting them to the next level. And there will be work and the new jobs that we actually have not imagined just yet. And to finalize it, I have my own favorite job of the future, which is not here, that I would like to share with you. The virtual reality kit that is now becoming the mainstream thing, I would try to make a guess that in 5 years from now, maybe a bit more, it will be a gadget that you will be carrying in your backpack, the way you are carrying a smartphone now. And there will be guys who are 20 now, maybe they will be 30 then, who will be working anywhere, anytime, when they will put the VR kit and they will remotely work with some telepresence robot in some elderly care home. And this way they will completely on the other side of the planet make their living just because of this setup. And this work, for example, right now doesn't exist. And the final one is that we are all part of these decisions, especially about the future and the jobs. The trajectory of technological progress is inevitable, but it depends on the choices we all make. Governments tend to invest, consumers tend to buy, and businesses tend to produce and choose the technologies we use. So it's all still very much up to us. Thank you.